Hi everyone, this is Michael. In this video, I'm going to talk about LeetCode problem 102, binary tree level order traversal. So what is level order traversal? Given the root of a binary tree, we return the level order traversal of its node values from left to right, level by level. So let's take a look at this example. So the first level is 3, and the second level is 9, 20, and the third level is 15, 7. So as you can see, the output will be list of list, right? The first level is a list of 3. The second level would be a list of 9 and 20. The third level will be list of 15 and 7. So as you can see, the tree node structure is defined here. It has the int value and left node and the right node. So let's do some drawing here. I already drew the tree here. So we have to do the level order traversal. So like this, the first level and then the second level and the third level, right? So how can we do that? I guess we have to define a queue to do the level order traversal. So I already draw a queue here. So what can we do by using the queue to do the level order traversal? So at first we start from the root, right? So we push the root node to the queue. So for example, like 3. So and then we check whether the queue is empty or not. So if the queue is not empty, we pop the first element from the queue. So the queue is always first in, first out, right? So in this case, when we pop the root node 3 out, so tree node 3, we pop it out, and then we can check its left node and also the right node. So for the 3, its left node is 9, and then we push it into the queue. So 9 is in the queue, and then we check the right node, so it's 20. So we push it into the queue, and then we add the first level, create a list for the first level and add the 3. So it will be a list of 3. And then we add it to the result, right? So the result would be list of list with one list. And then we check the queue again. So for this case, the second level, we have 2 elements in the queue, right? So we have to do a for loop. So first we get the size of the queue, it's 2. And then we do a for loop. And in the loop, we pop the first element, and it's 9 from the queue. And then we repeat it for same stuff we did for the 3, like check its left node and right node, because 9 doesn't have any left node or right node, so we just add it to the list, so it's 9. And then so 9 is already popped, and then we pop the 9, pop the 20, sorry, and check its left and right. So left it's 15, right it's 7, so we push 15 into the queue and 7 into the queue, and 20 we already popped, and then we add the 20 to the list. So in this case, the result would be right, and we repeat the same thing we did for the second level. So for the third level, we pop 15, check its left and right. 15 doesn't have any left and right, so we just add it to the list. 15, and then we pop 7 here. And 7 also doesn't have any left and right, so we add 7 here. And lastly, we update the result to be, sorry, I miss 3 here, and 9, 20, and then 15, 7. Okay, I need to. All right. So, and then the queue become empty. So we finished the loop. And the time complexity for this algorithm is O(n), right? Because we visit every node just one time. And also for the space complexity is also O(n), because we use the queue to store all the nodes. So that's it. Let's write some code in Java. So first we define the return value. So it's a list of lists, integer, and the result. So new it as a array list. So for the corner case, if the root is none, we just return an empty list. And then we need to define a queue, right? So the queue will store the tree node when you are linked list here. And then we need to push the root node into the queue, and then we start the loop, while loop. So for the while loop, we check whether the queue is empty or not, and then we do do you remember we need to do the for loop here, right? So first we need to get the size of the queue, and also we need to create a list for store the elements for the level, right? So here I define another integer of list, and a new array list here, and then we do the for loop. So inside the loop, we pop the elements from the queue, and then we store its value in a list, right? So and then we check its left node is none or not. So if it's not none, we add it to the queue. And we have to do the same thing for the right node, right? So update it to right. So when we finish the for loop for the level, we need to add it back to the result. So when the queue is empty, we have to return the result. So let's do some testing. So for this test case, let's run the code. It passed this test case. Let's submit the solution. It also passed. So we can see the Kotlin version is almost the same. And also the Swift version I have done before. So one thing we need to pay attention is that in Swift we don't have a linked list, so we have to use array instead. So that's it for this problem. If you like this video, please hit the like button, or if you haven't subscribed to this channel, please subscribe. Thank you very much.